All right. I'm looking. Still got 16. Still got 16. Okay, good. All right, I'm going to hit a few more. I can't remember what we went over and what we didn't go over. So somebody tell me what was the last problem we went over. If somebody can tell me, let me pick somebody so I don't have 15 people. Mr. Payella, which is the last one in your notes that we went over? I believe your mic's mute, but that's okay. Just unmute it.
So the last one I have down is a definite integral. It's 2 to 1 and then 2x dx on top and 1 plus x squared to the third power on the bottom.
Okay, give that to me again. I remember that problem. Give it to me again, the problem. I don't care about the parameters.
So is 2x dx on the top and then 1 plus x squared in parentheses to the third power on the bottom.
I got it. Okay, so here we go. I don't know. Let's see, where's my black pen? Everything's all over the place. My black pen has disappeared. There it is. All right, so handy dandy whiteboard. Here we go. And we've got antiderivative of 2 to 1 of 2x dx over 1 plus x squared to the third power dx. Okay, that's already there. And I think everybody knows that u is going to be equal to 1 plus x squared, and du is going to be 2x dx. We've got 2x dx, so we've got the antiderivative from 2 to 1 of du over u to the third power. So we can take that u to the third power upstairs, and we get 2, 1, u to the negative 3 du. And this is the form of the power rule, just with u instead of x. Now, there's two ways. I told you yesterday that you could back substitute and do the math, or you can convert the 2 and the 1 to u coordinates or parameters and plug and chug after you take the antiderivative. I really don't care which one you do, so I'm just going to go ahead and keep going, and I'll show both ways on the next page. This will be u to the u to the negative 2 over negative 2, evaluated at 1 and 2, and that's going to be negative 1/2, and u squared is going to be on the bottom, evaluated at 2 and 1. We're going to take this over to the next page and do it both ways. Okay. So we're going to get negative 1 over 2u squared, evaluated at 2 and 1. Negative 1 over 2u squared, evaluated at 2 and 1. So over here, we're going to do it the way we've been doing it. We're going to back substitute and plug and chug. Back substitute, plug and chug. So that's going to give us -1 over 2, 1 plus x squared squared, evaluated at 2 and 1. And I'm going to rewrite -1 over 2 parentheses 1 plus parentheses squared squared minus -1 over 2 times 1 plus parentheses squared squared. And I'm going to plug in a 2 right here. And I'm going to plug in a 1 right there. And this turns into a positive. So that's going to give us -1 over 2. Well, this is going to be a 5, a 25. Y'all check my math. Plus, and that's going to be 1 over 1 plus 1 is 2 squared is 4/8. So -1 over 50 plus 1/8. And I'm just going to leave that there right now. I'll write it a little bit clearer. -1 over 50 plus 1/8. Now let's see what we get over here. Now we got to change u. U is equal to 1 plus x squared. So we got to change these two numbers. So -1 over 2u squared, evaluated. 1 plus 1 is 2. And 1 plus 4 is what? 5. And that's going to be -1 over 2 parentheses squared minus 1, -1 over 2 parentheses squared. And I'm going to plug in a 5 right here. And I'm going to plug in a 2 right here. And what do we get, people? What'd y'all get? Y'all get the same thing?
Yep.
Yes.
So why do you do this? Personal what?
Preference.
It's a personal preference. I really don't care what you do, but I've done my job in showing you where this comes from, instead of being a calculus teacher that doesn't show you, and then when you see it in Calc 2, you're like, where'd those numbers come from? So you can either go with the 2 and the 1 and back substitute the equation back into the u, or you can just use u, change your numbers from 1 to 2 to 2 and 5. Question. And I don't know what that comes out to be. -150 plus 1/8. -1 divided by 50 plus parentheses 1/8. Did y'all get 0.105?
Yep.
I guess the common denominator would be 200. I got 21 over, write down 21 over 200 That's fraction. Everybody good? Y'all hold down your excitement. I know you're excited about learning how to do this. I know you're excited. How about this one? I don't know if I gave you this one or not. The antiderivative from 3 to 7 of x squared minus 9 dx. Did I give you all that one?
I don't
No.
think you did.
I'm sorry, what?
You didn't.
I didn't?
I don't think
All
so.
right, let's do that one. My goal here at the end of chapter 5 and 6 is for you to say, well, this ain't difficult at all. That's my goal. And hopefully some of you are seeing that substitution and definite integrals is not difficult at all. All right, somebody tell me what u is going to equal.
X squared.
X squared what?
Minus 9.
X squared minus 9. So du is equal to 2x dx. Well, we don't need now I'm showing you this one. We don't need to use substitution on this one. How do I know that? Well, the 2x, that's impossible. I can't multiply this by 2x. If you multiply it by 2x, that's just going to make up things. So when you do substitution and it looks like you can't do it, that means that you got to fall back on the power rule. So since I can't use substitution, fall back on power. So this is going to be 2 or x to the third over 3 minus 9x evaluated at 3 and 7, or 1/3 x cubed minus 9x evaluated at 3 and 7. And I'm going to write down one more, or, yeah, that's good. We don't want to do anything else. All right, plug and chug. See what you get. So parenthesis cubed over 3 minus 9 times parenthesis minus parenthesis cubed over 3 minus 9 times parenthesis. And of course, this BA line right here means I'm going to subtract these guys. And this guy is the bigger guy, so he goes first. And this is the smaller guy, so he goes last. So this is 343 divided by 3 minus, heaven forbid, 63 over 1 minus 27 over 9, I'm sorry, 27 over 3 minus 27 over 1. Now, of course, you see we've got to get a common denominator. And I know that 27 over 3 is 9. But that's not going to help you because, well, you could 9 times minus 27. Yeah, you could do that. But you still got to get a common denominator here. So I'm just going to get a common denominator all the way across the board. So 343 over 3 minus 63 over 1 27 over 3 minus 27 over 1. And it's not like y'all need help. I mean, y'all are the generation that can't read a ruler. So we need to do all the fractions we can do. All right, common denominator is 3, so we're going to put a 3 here, 3 here, 3 here, and a 3 there.
That'd be 63 over 1.
Well, where did I get 61? Thank you. All right, so minus there and a minus there. That'll be 343. 1 will go into 3. 3 times, that's 189. Y'all check me. And then 3 will go into 3, that'll be 27. And 1 will go into 3. 3 times 27. Yeah, 1 will go into 3. What's 3 times 27?
81.
81. I thought it was 81. And that's going to be 154 over 3. Minus a negative. What's 27 minus 81?
Message coming in on secured channel.
Let's see, 454. Somebody check my math.
That's right. Negative 54.
And I get 208 over 3. What'd y'all get?
That's what I got.
Now, the reason somebody sent me this is because in the book, it gives you some long explanation with sigma in the homework. Just find the derivative. I told you I wasn't going to go through Riemann and sigma. I'm not going to go through all that. Okay? Because it's not important. It is important, but it's not important. Okay? If in a summer class, if this was a fall or a spring class, I would have more time to go into Riemann and sigma and all that. But I have two options. I can go over antiderivatives more, or I can go over antiderivatives less. And I'm picking to go over antiderivatives more. Okay? So when you see one of those in the homework and it says, I think it says find the area using the derivative theory or something like that, just find the antiderivative. All right, let's see if I got a couple of more here. I don't know if I've covered them or not with you, but I'm gonna cover them. Let's see if y'all done this one. Antiderivative 0 to 1 of x times x squared plus 1 to the third power dx. Look through your notes and see if we've done that one. I don't think we have, but anybody see it? Okay, I gave y'all enough time. Go ahead, let's do it. Unless somebody sees it. I don't think anybody sees it. I think this is a homework problem sent in. I don't know which one it is, but first thing I'm going to do is rewrite it. 0 to 1 of x squared plus 1 to the third power x dx. And of course, u is going to be x squared plus 1. And du is going to be 2x dx. So what do we got to add to it?
2.
And we got to put what on out front?
1/2.
And this turns into du. And this is u to the third. I think we've done one like this, but I don't think we had parameters with it. Either way, it's more practice. So 1/2 antiderivative from 0 to 1 of u to the third power du. And that's going to give you u to the fourth, 1 over 2 times u to the fourth over 4, evaluated at 0 and 1. And that's going to give you 1/8 u to the fourth, evaluated at 0 and 1. What's the good news?
The 0 cancels.
0 cancels, so you don't even have to worry about 0 because it's going to cancel the whole thing out. So all you got to do is plug 1 in and tell me what you get.
1/8.
Nope. You didn't convert. What is that upper limit? If you're going to plug it in for u, what's that upper limit?
2.
And what's 2 to the fourth power?
16.
So 16 over 8 is what?
2.
2. That's a good test question. The reason that's a good test question is because it comes out to be an even number or a whole number. At least if we did the math right. Let's say 1, plug that in here. That's 1 squared is plus 1. 1 plus 1 is 2. So 2 to the fourth, I believe, is 16. And then take 16 divided by 8. Good job. Okay, now I'm going to move a little bit. So, because I know some of y'all have done your homework, and that's good, we're going to move over to 6.1. We're going to do a few things with 6.1 because I want to spend probably the rest of the week, today and tomorrow, working on 5 and 6. So here is, I want you to write down the blue and the brown. Write down f of x is equal to 5 minus x squared. I wouldn't write it like that, but That's the Tide Pod Generations way of writing it. So I'm going to get a blue marker. And f of x is equal to negative x squared plus 5. And I'm going to get a brown marker. Yes, I do have brown. It's kind of bronzy. But g of x is equal to x minus 1. Now, we're not going to use this because we're going to do it by hand. Take our handy dandy. There's our, and we're going to draw a big, because I'm fixing to show you how to do the difference between two curves, the area between two curves. This is 6.1. First thing you want to do, in red, number 1, graph, sketch. Now, I'll tell you right now, if you're working on a test, you're going to handily use your calculator to graph. You don't have time on tests to sketch. Do it on your homework so you can understand what you're doing. Do the sketch after you graph it on your calculator. Number 2, find intersections. In your calculator, I showed you how to do that throughout the semester if you didn't know. Go to second trace and find the intersection points. Number 3, set up your integral. And then, of course, number 4, do the calculus, do the math. 4, do the calc. Meaning take the antiderivatives and do the what you're supposed to do. So negative x squared plus 5. That means we've got a parabola. 1, 2, 3, 4, 5, and it's opening downward. Like that. And x minus 1 has got a y-intercept of negative 1. And this is 1 to 1. So that's a 45-degree angle. 1, 1. Oops, I'm sorry. 1, 1, 1, 1. So we've got a brown line with something like that. Everybody with me? So what do we got to find? Well, we got to find the intersection points. So I'm going to use another color. I don't know what color to use. I'm going to use this yellow. And we've got to find this intersection point. And we've got to find this intersection point. Because the intersection points is our parameters for our area between the two what? Between the two curves, Hubert. That's right, class. Thank you. It's always good when you're in a board meeting or a, director's meeting to communicate with the director or the, CEO or the president or whatever the case may be. But some of y'all are going to sit there like a bunch of introverts And the boss is going to get mad. Just keep practicing it. That's good. Keep practicing it. You'll end up in that janitorial closet before long. Okay? So, how are we going to find, somebody tell me, whether you've done it in algebra or done it in pre-cal, how do you find, and not on the calculator, how do you find the intersection points between two graphs? I'm just waiting for y'all to unmute your mic and tell me.
Priority 1 message coming in on secured channel.
How do we find those intersection points? Go ahead, unmute your mic and let me know.
Oh, can you take both functions and like solve it as a system of equations and then
Set each function equal to each other. Yes. Mr. Payella, you're a good man.
thank you.
Set functions equal to each other. Why is this so important? Because you're going to be asked to do this on a standardized test between now and whenever you start your career. Because somebody, whether it's going to be a GRE, whether it's going to be an employment test, whether it's, if any kind of test, they're wanting to know how to find the intersection points. And yes, you can find it with your calculator, but you might not be able to use your calculator. So here I'm going to set negative x squared plus 5 is equal to x minus 1. And I want y'all to solve that, please. Because all of you have been through algebra. Y'all should be able to solve that. Bring the x and the 1 over. Solve it. Are you going to use complete the square? Yep. Negative x squared plus 5 minus x plus 1. Negative x squared minus x plus what? 6? And that's going to be negative x squared minus x plus blank is equal to negative 6 plus blank. Factor out a negative 1. That's going to be x squared plus x plus blank is equal to negative 6 plus negative 1 times blank. And half of 1 is 1/2. 1/2 squared is 1/4. So negative 1 times x plus 1/2 quantity squared is equal to negative 6 plus a quarter, or plus a negative quarter is negative 6 1/4, which is 6.75, or 6 1/4. And now we can solve for x. That's what we need to do, is solve for x. So we've got negative 1 x plus 1/2 equals, and I'm going to change that back to a fraction so I can do it. I can't do it with a mixed number. So is that 25/4? Somebody check me, please. I think that's right. Divide by negative 1, divide by negative 1. X plus 1/2 quantity squared is equal to 25/4. x plus 1/2 is equal to 5/2, positive or negative. And positive 5/2 minus 1/2 is what? 4/2, which is 2. And negative 5/2 minus 1/2 is negative 6/2, which is negative 3. So our intersection points are negative 3 and positive 2. Sorry. So our area is going to be from negative 3 to positive 2. So that's our area. So I'm going to set up my parameters and my antiderivative. Wait a minute. How do you set up your antiderivative? What's the equation going to be? Well, it's always going to be f of x, antiderivative, from a to b, of f of x minus g of x dx. That is the area between two curves. You always want to take, and I always take the larger one. How do I know the larger one? Which one gives you a bigger y value with the x value? Which one gives you the biggest y value for each x? Which one?
X minus 1.
No. We'll plug in. Pick a number.
5.
Okay. What's 5 minus 1?
4.
What's negative 5 squared?
Oh, my bad.
You're going to get a bigger number with this one. See right here?
I figured you did the exponent first, and then you put the negative in.
Well, you got to look at your graph. See your graph right here? The blue graph, or the f of x, gives you bigger y values for the area that you're measuring. See, here's the area that you're measuring. Your biggest y value, see, here's the y values for this line at, let's say, negative 2. Negative 2, your y value for the brown line is down there. Your y value for the blue line is where? Right there. So this, for the area that you're trying to find, this is your dominant. That's your dominant. And then this one, of course, is your weaker. So because it doesn't give you as high values. So you're going to subtract this one from this one. Okay, does everybody understand what I mean by dominant? Okay, it's the one that puts out the highest what? Y values for the section that you're this section right here. Does everybody understand what I mean by the higher Y values? I just need one person to shake their head. Well, we don't have, now we've got a window, a ceiling fan, a ceiling, a wall. Yeah, thank y'all. All right, so I'm going to set up my antiderivative. And it's going to be antiderivative from negative 3 to 2 of x squared plus 5 minus x minus 1. Now I want you to combine. You're going to use the power rule. You're not going to use substitution because it's just, you know, it's just adding and subtracting. And plug and chug and evaluate and give me the area of the yellow stripes. Give me the area for that yellow area. Go ahead and get to work. Give you a minute.
Priority 1 message coming in on secured channel.
All right, so I'm going to go ahead and combine. That'd be 2 to negative 3, negative x squared plus 5 minus x plus 1. And that's going to give me negative x squared minus x plus 6 dx. And that's going to give me negative x squared third divided by 3 minus x squared divided by 2 plus 6x, evaluated at negative 3 and 2. So I've got to write negative parentheses cubed over 3 minus parentheses squared over 2 plus 6 times parentheses minus negative parentheses cubed over 3 minus parentheses squared over 2 plus 6 times parentheses. And since this is my big number, it goes here, here, and here. And since this is my smaller number, negative 3, negative 3, negative 3. Let me go ahead and stress to everyone, and this is a pink highlighter. I want you to write this down right here. Somebody tell me what this is called. I told y'all the other day. What is that called before you do all the math? What is that called? Anybody know?
A definite integral.
It's called the setup. Sometimes on a test or a homework or just while a teacher's teaching, they'll just say, give me the setup for the antiderivative. Is that something that you might want to make a note of? Yes. Because sometimes the homework or a test or your teacher in Calc 2 will just say, give me the setup. They might ask for this setup. They say, give me the setup and then take the antiderivative. There's the setup. All right, so let's see what happens with this. This is negative 2 to the third power is negative 8/3 minus 4/2 plus 12 over 1. And yes, I'm leaving everything a fraction because if I start changing stuff to whole numbers and decimals, I have to use a calculator and depend on it. minus, well, that's -3 to the third power is negative what? 27 with a negative in front of it would be positive 27 minus 9/2 minus 18/1. Excuse me. Oh. All right, we got to get a common denominator, and we know the common denominator is 6. So I'm going to rewrite mine. Six, 6, 6. Minus 6, 6, 6. And 3 are going to 6. 2 times 8 is 16. 2 are going to 6. 3 times 4 is 12. 1 are going to 6. 6 times 12 is 72. 3 are going to 6. 2 times 27 is 54. 2 are going to 6. 3 times 9 is 27. And 1 are going to 6. 6 times 18. 108. Somebody check me, please. What's 6 times 18?
That's right.
Okay. This is -28/6 plus 72/6 minus 54 minus 27 is 27/6 minus 108/6. 28 plus 72, I have no earthly idea. I'll have to do it in my head. Let's see. 72 be a 4 and 44. Somebody check me. What's 72 minus 28?
It's
72 minus 28. What is it?
44.
So that'd be 44/6 minus, and let's see, 108. That'd be a 1 and 10 minus 81/6. What's 108 minus 27? 81?
81.
And then these two turn into a positive. And that's going to give me 125/6. Somebody check me. What's 81 plus 44?
125.
So your answer is 125/6. So the area under this curve is 125/6 square units. Somebody divide 125 by 6. What do you get? Like 20, what? $28?
20.83.
20.83? $20 square units, 21 square units. Ain't that neat? And ask yourself, I want to ask you something. What's harder, the calculus or the math?
The algebra.
I didn't, that's not a choice. I didn't give you a choice of algebra. I said, what's harder, the calculus or the math?
The math.
The math is. Thank you. Thank you for the one person that always communicates because everybody else is weaned on a pickle.
Hey Hubert, my
Yep.
my laptop's about to die. I don't have my charger. Can you go ahead and count me absent or
I'll
here for
count you
today?
here.
All right,
You go ahead and just stay until you die. All right?
all right.
Okay. Let's do another one. Do one more. We got a few minutes. Let's, oh yeah, there you go. Try those two. F of x is equal to negative x squared plus 2x plus 5. And g of x is equal to x cubed minus 3x squared minus x plus 5. And we got some kind of sketch here. And the blue line goes up. It's just a regular parabola. 1, 2, 3, 4, 5. And what is that? Negative 0.75. And positive 2.75. So that graph looks something like this. There's the parabola. And then we've got a cubic function. And it's crossing at negative 0.6 maybe. Negative 0.6 right here. And then up to 5 is crossing, got a hump there. And then down to, looks like what, negative 2 1/4 and negative 1, 2 1/4 and negative 1, about right there. And then got a, yeah, and then up. Okay, so it looks something like, hope I can draw this. I'm trying to draw it. This looks awful, but I'll do the best I can. Like that, something like that. Okay. Oh, we didn't check our last one, did we? Let's see what the, no, I don't want to do that. There we go. See if I can stop it. What did we get? Somebody tell me, what did we get? I done lost my paper. What did we get? 20 point what?
20.8.
20.83. Oh my gosh, look at there. It's a miracle. The computer got 20.83. Okay, now let's go back to this one. Sorry about that, I forgot. All right, here we go. There's our drawing. And we've got to find this point, and this point. So we got to set them equal to each other. So Now, on a test, you would use a calculator to find them. But here we're going to do it by hand because you never know when somebody might ask you to do this on a test. Negative x squared plus 2x plus 5 is equal to x cubed minus 3x squared minus x plus 5. And since it's a cube, it's going to be a lot of algebra. So I can tell you right now that we're probably going to go to the calculator because you're going to have to use long division, and that's just too much right now. I'm going to leave that x cubed alone because it's positive. So I'm going to bring this over. So that's going to be a plus x squared and minus 2x minus 5. And that's going to give you 0 is equal to x cubed. Negative 3x squared plus 1x squared is negative 2x squared. Negative 3x. And then that cancels. You could factor out x, make things a whole lot easier. That'll leave you with x squared minus 2x minus 3. And x is equal to 0. That's one of your intersection points. And x squared minus 2x minus 3. Might can use reverse FOIL on this. Negative 3 and a positive 1. So negative 1 is an intersection point, and positive 3 is an intersection point. So let's go back to our, so 0 right here, x is equal to 0. Negative 1 is right here. And positive 3 is right here. So there is your intersection points. So you're going to find the area from negative 1 to 0 and from 0 to 3. Negative 1 to 0, and that's going to be this term minus this term, plus from 0 to 3 of this term minus this term. So I'm going to set it up for you. So the area right here is going to be from negative 1 to 0. And since this area is got this on top, we're going to subtract this from this because this is the dominant, or this pink area, this is the dominant. So I'm going to say antiderivative from negative 1 to 0 of x to the third minus 3x squared minus x plus 5 minus x squared plus 2x plus 5. All right, that's the area of the pink region. And I'm going to take my marker. And that's the pink region. Right there. I'm going to color this one in yellow. And the dominant region there is the blue from 0 to 3. So I'm going to add from 0 to 3 negative x squared plus 2x plus 5 minus x to the third minus 3x squared minus x plus 5. And of course that should have a dx, and this should have a dx. And that is my yellow region. So you've got, trying to get this all on one page, I'm sorry. You've got the pink region from -1 to 0 with your brown minus the blue. And then plus from 0 to 3, the blue minus the brown. Now, what do you notice about the way that I do these? Very, very methodical, very step by step. Some of y'all, as students, y'all try to go from the first question, you try to go to here in like 2 seconds, and it doesn't work that way. All right, I want y'all to work on this for homework along with your other homework. You don't need to be trying to get into 1.6 homework tonight. You need to be trying to send questions, and tomorrow we'll go through a lot of questions, homework questions. Okay? I just wanted people to be able to do this over the weekend if you finished your Chapter 5 homework. All right, let me get the roll. And shut off the recording.